Hello everyone, this is Kevin Zhao, your finance professor at MTSU. In modern history, about the safest investment available has been US Treasury bonds. And low risk means that the US Treasury bonds paid a lower return or yield than other bonds. However, in February year 2010, issuer Berkshire Hathaway issued bonds with a lower promised yield than Treasury bonds. Berkshire Hathaway was not alone. Procter Gamble, Johnson & Johnson, and Lowe's all will be able to sell bonds with lower promised yields. So what happened? Apparently, the bond market was saying that those four corporations have a lower risk than U.S. government. In August year 2011, credit rating agency S&P agreed when they lowered the credit rating on U.S. Treasury bonds from AAA to AAA plus. Other countries had similar experiences. About the same time, Japan's government debt was downgraded, and on a single day in January year 2012, 9 nations, including France, Spain, and Italy, received downgrades on their government bonds. This chapter takes what we have learned about the time value of the money and show how it can be used to value one of the most common instruments, financial instruments, bond. It then discussed the bond features, bond types, and operation of the bond market. Our goal of this chapter is to introduce bonds. We begin by showing how technique that we developed in chapter 4 and 5 can be applied to bond evaluation. From there, we'll go on to discuss bond features and how bonds are bought and sold. One important thing that we learn is that the bond value depends on interest rates. Therefore, to conclude this chapter, we will have a thorough examination of interest rates and the term structure of interest rates. At the end of this chapter, you should be able to know the important bond features and different types of bonds, and you should be able to understand the bond value and what are why bond price fluctuate. And also you need to understand the bond rating and what do they mean. Of course, you need to understand the impact of inflation on interest rate and what the term structure of interest rates mean and what are determinants of bond yield. And here the chapter outline, we will discuss 7 different topics associated with bond and bond features. First one is to define a bond and introduce the methodology for bond valuation. And second, we'll learn more about the bond features. And the third is bond rating or credit rating. And the fourth one is different types of bonds. Fifth one is the bond market and how bond market operates. And the sixth one is the relation between inflation rate and the interest rates. And the last one is determinants of bond yield. Now, let's take a look at bond definition. A bond can be defined by 4 dimensions. The first one is par value, second one is coupon rate, the third one is maturity date, and the last one is yield to maturity. So bond essentially represents a lending and borrowing relationship between bond issuer and the bond holder. And any bond carries interest. It's like interest carrying loan. And bond represents a contract, of course, between bond issuer and the bond investor. Par value here is the face value of the bond. That is the amount of money that the bond investor will receive at the end of its maturity. Conventionally, it's defined at $1,000 for both U.S. corporation, and U.S. government bonds. And the coupon rate defines amount of interest that investor can receive from holding a bond, and the coupon payment equals coupon rate times $1,000 of its par value. Maturity date defines when the bond will become mature, and the year to maturity gives some idea on what the bond return will be for bond holders. And here's more information about the par value and coupon interest rate. And a lot of people use coupon interest rate as an indication of bond investment return, but This number has nothing to do with bond investment return. It is simply telling investor what coupon payment that they will receive every year. And sometimes coupon rate can be equal to year to maturity, but it's not always the case. Year to maturity, or YTM, is a pretty good measure of bond investment return. It is discount rate that equalizes the bond price and its and present values of all coupon payments and principal payment. As I said, sometimes year to maturity can be equal to coupon rate, but in other cases they may not be equal to each other. Now let's take a look at how we can determine a bond price based on its future coupon payments and principal payment, or par value payment. As a bondholder in the future, it's definitely they will receive coupons on an annual basis, and at the end of maturity they will receive full amount of payment of principal, or the par value, that $1,000. By applying the time value of the money principle that we learned in previous chapter, we know that the value of bond is determined by, first, present values of all of the coupon payments they will receive in future years, and the second, the present value of the last principal payment. So it's discounted cash flows that investor will receive in the future in terms of both coupons and principal payment. And all of the cash flow need to be discounted by using a proper interest rate. So if interest rate increases, that will make present value smaller. And here, remember, higher interest rates will depress bond prices. When interest rate declines, it will boost bond price. So often, when you hear any announcement of Federal Reserve, you need to pay attention to that announcement, because typically the movement of interest rates by the Federal Reserve will have a huge impact on bond price. Let's say Federal Reserve decide to raise the interest rates. What does that mean to bondholder? Well, it is a bad news, because higher interest rates will depress present values, therefore bond prices. On the other hand, if Federal Reserve decides to cut interest rate, then it's a good news, because lower interest rate will boost the bond price, and it will benefit the current bondholders. Now let's take a look at the bond pricing equation. And this equation actually gives you a shortcut to get the present values of all coupon payments. And the C here is the coupon payment, and F is the principal payment, or the par value payment. And here YTM is the interest rate that we use to discount those cash flows. Many people do not like this equation because calculation can be very complicated, but I want you to know that you have a friend who can assist you in calculating bond price. That is your financial calculator. And here you see BA2 plus Texas Instrument financial calculator. And this calculator can help you to calculate the bond price. And you can get a correct answer for bond price in less than 30 seconds. Alright, let me introduce the method that you can utilize to calculate bond price on this calculator. Alright, notice that on the third row of this BA2 calculator, you have 5 gray keys. The first one is N, second one is IY, third one is PV, fourth one is PMT, and the last one is FV. And the N here represents the number of coupon payments, or the number of time periods in a bond. And this IY is the return on the bond, right? And that is yield to maturity, or YTM, not coupon rate. IY is yield to maturity. IY is not coupon rate. And the PV is the present value. And in the context of bond valuation, it is bond price. And the fourth key here, PMT. PMT is a payment or periodic payment, and for bonds, that is annual coupon payment or periodic coupon payment. And the last one, FV, of course, is the par value or principal of the bond, and typically FV is $1,000. Now, in addition to calculator, you can also seek help from your Excel spreadsheet, and Excel spreadsheet has automatic function that you can utilize to calculate not only bond price but also year to maturity, number of time periods, payments, so on and so forth. Right? And essentially, you have 5 variables in your calculation. The first one is PV, which is the bond price. Second one is PMT, the coupon payment. Third one is number of time periods. Fourth one is IY, the interest rate. And the last one is principal payment. Right? And once you know 4 of those variables, you can calculate the 5th one. For example, in this second calculation, this PV is bond price. In order to calculate bond price, you need to know, first of all, this rate, the year to maturity. Second, number of time periods. Third one, the amount of coupon payment, or PMT. And the last one is principal payment. You can also use TI-BA2 calculator to calculate bond price, but I will not introduce the details of this operation. And I think if you are comfortable with BA2 a tax instrument, that will be sufficient. Now let me demonstrate an example to see how you can use BA2 calculator to calculate bond price. As I said, you can complete the calculation within 30 seconds. Right? First step is to identify those key variables. Right? Notice that we are dealing with the 5 variables, and the answer that you need to get is PV, or bond price. In order to get a bond price, you need to know 4 other variables. First of all is number of years, and in this case, this bond will mature in 5 years, therefore that n should be 5. And the second one is yield to maturity. Yield to maturity is the interest rate or discount rate, and in this case is 11%. And the third one is payment, or coupon payment, or annual coupon payment. Since coupon rate is 10%, therefore payment can be calculated as product of 10% and a par value of $1,000. That gives you $100 annual coupon payment. So payment should be 100. And the last variable, FV, is the principal payment, and by convention, it's $1,000 for both U.S. corporation bond and the government bonds. So on your calculator, you need to enter those 4 variables. So first step is to press N followed by 5. Then you press IY and enter 11. Why 11, not 0.11? Because your calculator recognizes that 11 as 11%. So 11 here means 11%. The third one is PMT. You press PMT and enter 100. And the fourth key is FV, then you enter 1000. Once you complete inputting those 4 variables, then it's time for you to get PV. Before you press PV, you need to give your calculator the command to compute, which is CPT. The first key on the first key on the first row, that is CPT. CPT means compute PV. Then your calculator screen will show negative 963.04. That means the bond price is $963.04. Why does it carry a negative sign? Your calculator is very sensitive to the direction of cash flow. Positive number means the money that you will receive. And the negative means the money that you needed to spend. So if you're receiving coupons and principals in the future, the investor needed to pay money to buy a bond today. So negative sign here means investor pay money as cash outflows. Right? That is a very simple way that you can go through to calculate the bond price by using BA2 calculator. The alternative method is to do manual calculation by utilizing the formula that you see here, right? And in this formula, you need to put coupon payment C, F is the principal value, and the T here is number of years, and YTM is the interest rate. So when you put those four numbers into this equation, 100 is coupon payment, this 1000 is the principal payment, and 80% here. 80% here is the interest rate or year to maturity, and since I'm sorry, that's another example. By the way, once again, coupon payment is $100, $1,000 principal, 11% the year to maturity, and the number of years is 5. Right? When you put those numbers into your formula, you will come up with exactly the same answer, 963.04. And the last method is to use your Excel spreadsheet, right? And you simply utilize PV function within Excel and enter 5 numbers. The first one is the interest rate or year to maturity, and here you need to use 0.11. And the 5 is number of years, and followed by coupon payment 100 and 1000 principal value, and the last one it gives you choice of either one or 0, and here you choose 0. Why 0? 0 means cash flow occurs at the end of each time period. If you choose 1, that means cash flow occurs at the beginning of each time period. And notice that in this case, bond investor pays $963 to buy this bond, to receive $100 coupon payments for the next 5 years, and at the end, investor will also receive $1,000 principal payment. And here, bond price is less than bond par value, and in this case, we call this bond as discount bond. Is discount bond a good deal? I mean, you would say, hey, that's a good deal because you pay less than $1,000, right? But here, discount bond doesn't mean a good deal simply because for discount bond you get less. Why less? Look, your coupon rate is 10%. It's less than current interest rate of 11%. Right? The price is discounted, but you get less in terms of coupon payment relative to interest rates. Here's an example showing you how you can use calculator, manual calculation, and Excel spreadsheet to fix the bond price. And my favorite method is BA2 calculator. I simply put N20, IY8, PMT100, FV1000. Then I press CPT PV. And the calculator will show me $1196.36, which carries a negative sign as a result. And here I know that the bond price should be something around $1,200. Right? And in this case, investor pay more than $1,000 to get this bond, and we call this as a premium bond. Is a premium bond means a bad deal? Well, probably not, because on the financial market, you always see failed trades, failed deals. The reason why you pay premium is because you are getting more. Notice that the coupon rate is 10%, and the year to maturity is only 8%. Right? Required interest rate is 8%, but you are getting more in terms of coupon payment, which is 10%. So for premium bond, investor pays more, but they get more in terms of coupon payment relative to interest rate. This picture showed you the relationship between bond price and the yield to maturity, right? And on the x-axis, that is yield to maturity. On the y-axis, that is the bond price. And this red line, downward sloping red line, showed you a negative relationship between interest rate yield to maturity and bond price. Or we can say that there is an inverse relationship between bond price and the interest rate. Right? For example, when interest rate was low, let's say around 3%, and this bond will have price that is higher than $1,400. But when interest rate increase towards 12%, look, bond price declined dramatically to a level that is lower than $800. Alright, this is the 30-year Treasury bond. This is the 30-year Treasury bond issued by U.S. federal government. And in most cases, you would say this is the most safe assets in the world, because U.S. government will pay back coupons and the principal as they promised. And also the credit rating was one of the highest one, AAA or AAA minus. But how come investors can lose money based on their investments in U.S. government bond? Well, the simple mechanism here is interest rate. Interest rate. Higher interest rates depress bond price. Right? Although you are definitely will receive coupons principals as what the government promised, but the future money that you will receive will have less value due to higher interest rate, because higher interest rate means higher inflation rate in the future, and inflation will eat up your purchasing power. And bond price show you exactly how much purchase power that you are gonna lose based on higher interest rate. So this picture show you the most important thing for bond valuation: the inverse relationship between interest rates or yield to maturity and bond price. Higher interest rates or higher yield to maturity means lower bond price, and a lower interest rate means higher bond price. And also we discovered a relationship between bond price and the relative relation between coupon bond and the yield to maturity. And bond price could equal to its par value, but sometimes can be less than or greater than par value. And here the bond price, here if bond is issued at discount or premium, is depend on the relation between coupon rate and the yield to maturity. If those two percentage equal to each other, then price should equal to its par value of $1,000. But in case that coupon rate is less than or greater than the yield to maturity, then the price will be less than or greater than its par value. Right. And in the first case, we call it as discount bond. In the second case, we call it as premium bond. But no matter it's discount bond, premium bond, it doesn't mean you will have a good deal or bad deal, because bonds will be discounted for certain reason, and the bonds is selling for premium price for a certain reason. And if you are getting discount bond, you pay less, but you will get less. If you pay premium, a premium bond, then you will get more. And this picture shows you the price path of premium bond and discount bond over time. As you see, the premium bond has higher than $1,000 initially, and the discount bond has lower than $1,000 price initially. But over time, the price will move towards its principal value of $1,000, because no matter it's premium or discount bonds, at the end of term to maturity, investor will receive $1,000. So here you see premium bond price will decline gradually towards $1,000 over time, and discount bond price will gradually increase towards $1,000 at the end of the maturity. So far so good. The calculation is pretty straightforward, no matter you use calculator or Excel, even when you need to do manual calculation, I would say it's not a big deal for you to get a bond price. But in reality, U.S. government and U.S. corporation added a little complexity to our calculation, because so far we assume that coupons are paid annually. Right? Coupons are paid annually. But what happens on the financial markets is that both U.S. government and the U.S. corporation pay coupons semi-annually, which means they pay coupons twice. For example, if coupon rate is 10%, you will know that the annual coupon payment would be $100, right? And here, of course, the U.S. corporation and the U.S. government pays that amount of coupon on an annual basis, but they pay that $100 semi-annually, which means they pay $50 for the first half year and $50 for another half year. So this semi-annual coupon payments adds a little complexity to our calculation because the nature of cash flow has been changed. Although total amount is the same, but the timing of those coupon payments has been changed. So we needed to make some modification on our calculation to get the most accurate answer. And this formula showed you how can we calculate the bond price based on semi-annually paid coupon bonds. As you notice, this coupon rate has been you need to divide this coupon payment by 2, and also you needed to take half year to maturity in your calculation, and the number of time periods has been doubled. So essentially, we needed to do 3 modifications when you do semi-annual bond valuation. First of all, we need to double the time periods because the number of coupon payments has been doubled. And we do we do calculations on the semi-annual basis. For example, if maturity is 7 years for a bond, therefore the number of coupon payments, the semi-annual coupon payments would be 14. And the second, semi-annual coupon payment need to be adjusted, and coupon rate is 14%. That means annual coupon payment would be $140, but on the semi-annual basis, it's going to be $70 semi-annual coupon payments. And the last one is year to maturity, and here calculations are based on semi-annual basis. Therefore, year to maturity should be half of annual year to maturity, which is 8% in this case. Once we complete our adjustment, then it's pretty convenient for us to utilize calculator. Utilize calculator to do the calculation. Here, you put a 14 as number of time periods. And the year to maturity should be half of your annual year to maturity. And the payment should be half of your annual coupon payments. And the only one thing that doesn't change is the principal of the bond, which is $1,000. Right. So what you need to do is, first of all, double the time periods, and the second is to take half of your interest rate and half of your annual coupon payment. Then you press CPT PV to get the bond price, which is $917.56. And you can apply the formula to do the calculation. Once again, you do 3 modifications. First of all, this C is half year coupon payment, and this year to maturity is a half year to maturity, and the third one is number of years, this 14, right? Which double is 2 times it's equal to 2 times 7. 7 is number of years in this calculation. Okay, so far we observe an inverse relationship between interest rates or year to maturity and the bond price, and this relationship indicates that investors are facing risk of losing money for their bond investment, and the cause for bond price to decline is the increase in interest rates. Increase in interest rates. So let's go back to take a look at this picture. Look, let's say initially bond holder, bond investor bought this bond at a level that is higher than $1,400. By that time, the year to maturity was low, around 3%, right? And right now, interest rate has increased to 12%, and the bond price declined to less than $800. So in this case, the bond investor lost more than $600 due to increase in interest rate. So this increase in interest rates impose great risk to investors. Therefore, we call this as interest rate risk. Interest rate risk, right? So interest rate risk will cause bond price to decline, and we call this as price risk. And the longer term bond have higher price risk than shorter term bond, and also the bond with a low coupon rate will have higher price risk than high coupon rated bonds. And the second risk associated with bond investing is reinvestment rate risk. Right? Remember, when you have a coupon bond, you will receive coupons semi-annually or annually. Once investor receives those coupons, what do they do with those coupons? And most people will reinvest those coupons into another bond or into the same bond. And the reinvestment rate risk means when interest rate is getting lower, the investor can only reinvest those coupons at a lower rate. That causes some losses for their investments, right? And the reinvestment rate risk works at the opposite direction as price risk. They offset each other a little bit. Of course, the main force here is the price risk. Right? Price risk is much higher than reinvestment risk for any coupon bonds. Now let's take a look at this picture. This picture shows you how bond price changes for two different bonds. First one 30-year bond, the other one is a 1-year bond. And the pink line showed you how bond price changes due to change in interest rate. Right? When interest rate increases from 5% to 20%, this 30-year bond price declined from $1,700 to all the way down to $500. It's a very unfortunate event, right? But if you hold a 1-year bond, when interest rate increases from 5% to 20%, bond price, of course, declines, but not as much as you see for 30-year bond. It declined from $1,047 to $916. Right? So you see the magnitude of loss is much less for 1-year bond than 30-year bond. Therefore, a longer term bond is definitely more risky than shorter term bond, because for the same amount of interest rate increase, longer term bond will lose more in its value than shorter term bond. Okay, on the bond market, bond investors observe bond prices. Our first assignment was to calculate the bond price based on 4 variables: number of years, interest rate, the principal payment, as well as coupon payment. And here we assume we know the interest rate or year to maturity, right? But on the market, we do calculation on the opposite way. We see prices, and most people needed to figure out what a bond investment return will be, or what year to maturity will be, given a certain bond price. So in terms of the 5 variables, we know N, PV, PMT, and FV. And we needed to calculate that IY on your BA2 calculator. Now, this calculation is very complicated if you have to do it manually, and I do not recommend you to do any manual calculation where you need to get Well, you need to get yield to maturity, right? And your BA2 calculator will help you a lot in tackling this challenging problem. As a matter of fact, you can get the right answer within 30 seconds. Now, let's consider a bond with 10% annual coupon rate, 15 years to maturity, and a par value $1,000. The current price is $928.09. And here you have four guys. The first one is number of year 15, and the second is PV 928. The third one is FV, and the fourth one is coupon payment. 10% times 1,000, that gives you $100 coupon payment. With your knowledge for those four factors, then a calculator can help you to calculate yield to maturity automatically. Your yield to maturity automatically. So press N and enter 15. Press PV, then you enter $928.09. Then you press FV and put in 1,000, and a PMT put in 100. Then you compute IY. I'm sorry, here is a typo. You need to compute IY, and your calculator will show you results. And your calculator screen will show you 11. Right? 11 means 11%. If you're using Texas Instrument BA2 calculator, your calculator will show you error 5. It will not show you the result of 11% or 11. It will show you error 5. Why? Because this calculator is very sensitive to the direction of cash flows, right? And here, look, you put $928.09 as PV. That means you receive money. You receive money when you purchase the bond. Is that reasonable? Of course not. You need to pay money. And when you pay money, it's cash outflows. And on your calculator, it should be negative. It should be negative $928.09. And in the future, you will receive coupon payments and a principal. Therefore, those numbers should be positive. Right? So if you ignore that negative sign, your calculator will show you error 5. But don't panic. Just put a negative sign on your PV, and then your calculator will show you the correct answer. And you can do the similar calculation by using Excel spreadsheet. And notice that, okay, this PV should be a negative number. Sometimes we need to calculate year to maturity based on semi-annual coupon bonds, and here we simply make some necessary modification. The first one is double the time periods, right? And this PV is negative number. Remember that 1197.93 should carry a negative sign. And the second modification is coupon payment. Instead of putting 100 here, you put a 50 here. You put a 50 here, which is a half-year coupon payments. Then you CPT IY. Once again, you see a typo here. It should be CPT IY. IY is year to maturity. And your calculator will show you 4. 4 means 4%. But this 4% is semi-annual year to maturity. To get annualized year to maturity, you need to multiply this number by 2 to get 8%. Alright, so far we learned 2 techniques to either calculate the bond price or bond yield, or the yield to maturity. Right? And we have 3 alternative methods. The first one is to do the manual calculation. Second one is to use your BA2 calculator, and the third one is to use your Excel spreadsheet. And for most bonds, you know that in practice they are semi-annual paid coupon bonds. Therefore, in using those calculations, make sure you know how to do modifications. Right? For semi-annual paid coupon bonds, first of all, you need to double the time periods. Right? And the second, take half of the coupon payments as well as the half of the yield to maturity. Let's take a break, and we will introduce more information about bond features and type of bonds. But the hardest part has been accomplished, which is associated with the bond evaluation or bound calculation by using formulas, be it to calculators or Excel spreadsheet. Let's take a break.